and then over the concentration of CD. And so in order to get like the general expression for K, we have to arrange it in a way where they can cancel each other out, and then leave you with the expression of K. So this is K1, right? This is K2. Look over here, right? When you guys try to multiply it, C and D gonna cancel each other out and leave you with the overall expression. So that is the reason why, in order to find K over here, you're gonna multiply K1 and K2 with each other. And in reality, you can measure the concentration of the products and the reactant in any condition, and does not need to be always measured at equilibrium. So that is the reason why we have the Q quantity comes in. That represent like the concentration of the reactants and the product, but not at equilibrium. And so, but basically they still have the same expression, products over the concentration of the reactants. But remember, this one is not at equilibrium. And so when you have Q is less than K, your reaction gonna proceed forward, because like the value of Q show that like it's too small to reach equilibrium. So you have to increase Q, which means you have to increase your products in order to reach equilibrium. Q equal K, then your reaction is at equilibrium. Q is greater than K, it means like you go over equilibrium. So that's why you have to decrease your Q in order to move and reach equilibrium. So that's why you have to increase your reactance in this case. And then you have Le Chatelier principle. This kind of concept is always, I'm gonna guarantee you guys, like it's always gonna appear on the exam because it's very important. And so basically, the concept is just about a chemical reaction. We react in order to restore to equilibrium. And so over here, right, I have an example. You guys, like at this point, you guys have to understand how the reaction gonna shift and which direction they gonna shift. Is it gonna shift to the left or the right? Based on the condition that they give you guys have to understand how to do it. Okay. And how about, look at the example over here, right? I give you the reaction as well, and then how your reaction gonna shift if I remove water. You guys can put the answer on the chat. You guys don't need like to unmute and speak to me if you guys don't want to. But like, I just want to make sure you guys understand the Chatelier principle. Yes, it's gonna shift left. Yes. The reason why is because over here, right? When we remove water, it means we don't have a lot of reactants. So that's why in order to reach equilibrium, we need to react more reactant. So that's why the reaction gonna shift to the left. How about when you add more CO? Yes. So in this case, it's kind of opposite, right? Because in this case, you have more reactants. So that's why in order to reach equilibrium, you want to increase the product in order to reach equilibrium. It's gonna shift right, okay? How about when you remove H2? Yes, it's gonna move right. Because you don't have a lot of products. How about when you add more CO2? What's gonna happen? Yes, it's gonna shift to the left. Okay, this is very important concept, guys. So remember to. I know like some of you guys think like it's pretty simple, but I mean it's kind of like the main concept of chapter 14 as well, and also it's gonna able you guys gonna able to apply it to a lot of other like materials that gonna be appear later on as well. So it's very important to understand it. And then when you guys talk about exothermic and endothermic reaction, right? You guys need to be focused on like which side is the heat gonna be. When you have exothermic reaction, right? You're gonna release heat. So that's why you're gonna release energy. So that's why heat gonna be on the product side. And what happens if you guys increase the temperature? In this case, how the reaction gonna shift?
I love the colors.
Yes, it's gonna move left because when you increase temperatures, right, it means you release a lot of heat. So in order to reach the equilibrium, you have to shift to the left. Yes. How about when you decrease the temperature? It's gonna go to the opposite side, right? So it's gonna move to the right. And also for the pressure, pay attention on the how like when you increase the pressure or you decrease the pressure, what is gonna happen to. And so the concept over here is like when you have higher pressures, the more molecules that you have, right? When you in higher, if you increase the pressure, in order like to reduce the pressure, they're gonna move in a way where to the fewer molecules side. So for exothermic, when you increase the pressure, it's gonna shift to the right because when you release heat, you don't have that much molecules because like one of your other like it's gonna release as heat because you waste a lot of energy. So that's why in your product side there's not a lot of like molecules there. And so when you increase the pressure, that means like you have a lot of like molecules in the reactant side. So that's why you have to shift it to the right in order like to reach equilibrium.
Oh shoot, Zoom meeting is. I feel red.
And so when you decrease the pressure, it's gonna go to the opposite way. Now when you decrease the pressure, it means like they want to move to a direction where they can create more molecule. So over here, since you release heat, that means like this side doesn't have much molecules. Do not have much molecule. This side have more molecule. And so pay attention on this one too because that one already appeared on her exam in 2018, I believe. Yes. And for endothermic, it's gonna be in the opposite way where your heat gonna be in the reactant side. And when you increase the temperature, how it's gonna shift? Yes. Increasing pressure favor the side with less mole. Yes. How about this one over here for endothermic reaction? When you increase the temperature, how it's gonna, which direction it's gonna be? Yes, it's gonna move to the right because you have a lot of heat release. So in order like to reach equilibrium, then you have to shift to the right. How about when you decrease the temperature? It's gonna move to the left. So basically it's kind of opposite to the exothermic that we have over here. And so you have to consider when you increase the pressure as well. And then when you decrease the pressure. So when you increase the pressures over here, right? This side, because they release a lot of heat, they have a lot of heat inside. So that's why they doesn't have much molecule. Do not have much molecule. This one gonna have more molecule than the reactant side. So basically when you increase the pressure, it's gonna shift to the left because when you increase the pressure, it's one the reaction gonna favor the direction where they're gonna react less or fewer molecules. So that's why it's gonna shift to the left. And when you decrease the pressure for endothermic, it's gonna shift to the right because now they want to move in the direction where they can react more molecules. Then we can go to the catalyst definition. So for the catalyst, right, they're gonna increase the reaction rate by lowering the activation energy. In order to make the reaction happen faster, it's go past the barrier, right? But it doesn't affect the equilibrium constant. But it's gonna decrease the time to reach the equilibrium. So remember, like catalyst doesn't have nothing to do with equilibrium constant. And then we go to the free energy concept, right? Where we have the formula and at equilibrium, your delta G is gonna equal 0. So that's why when you plug in 0 over here, you got this equation. And also at equilibrium, K is equal to Q. So that's why you can replace Q here with K. And then you can able to find the expression of K by divided delta G with RT, negative RT. And then in order to cancel the log, you're gonna put it e to the power. So that is a way. I don't know if you guys still remember the math, how to cancel like the log. But like I want to put it here in order to remind you guys, if on the exam you guys have to separate the variable that have the log in the front. So like that is the way to do it. Just put it e to the power and then this gonna cancels out and leave you with the variable only. Okay. And over here, we got the Van Hoff equation. So for this problem, if she gonna give you guys on the exam, like if she asks you guys to calculate KT2 or like KT1, you guys know how to put it to e to the power of the whole things in order to cancel the log, and after that separate the variables. So yeah. And when your delta G reaction is less than 0, it means that your reaction is spontaneous, and so it proceeds in the forward direction and produce a lot of products. And they, because like it's favored products, so that is mean like you don't have a lot of reactant remaining. And the more negative the delta G is gonna be, the greater products you're gonna have before reaching the equilibrium. And when your delta G is less than 0, your reaction is non-spontaneous. So that is all of the main concept for chapter 14. And now I'm gonna put some of the problem that I create for chapter 14, and you guys can work on it. So number 1 is true or false. Okay. So catalysts affect the mechanism, which means the rate, mean the reaction rate. But not the balance, equilibrium. Which we saw. Okay. So for this problem over here, is it true or false? Remember, like I just go over like the definition of catalyst, how like catalyst and equilibrium doesn't depend on each other at all, and catalyst is only affect the reaction rate. It means like they can make the reaction happen faster by lower the activation energy. So in this statement over here, they tell you guys like catalysts only affect the reaction rate, but not the equilibrium. So it means the answer for this statement is true. The second question is gonna be, I'm gonna give you guys the reaction and then tell you guys to find the concentration of C at equilibrium. If half concentration of A equal to 0.100 m and B equal to 0.200 m initially, and your case C is equal 4. So what can you guys gonna do? Like just tell me the step. What is the first step that I have to do for this problem? Yes, set up K. But like before we set up K, what we can do? Yes, the rise table. So in order to set up K, we have to do the rise table. Okay, the reaction is over here. Okay, at the initial condition, what do you guys have and what did you guys don't have? Yes, we have A and B, but not C. Yes, C is the one where we try to find. So concentration of A is 0.000 m This one is 0.200 m. This one is 0. We don't have anything for C. And then we're gonna, because for this reaction, right, when you form a product, it mean in your change condition, it's gonna be plus so in the change condition, that is when you try to form more product. So in your reactant, it's gonna be minus X because you want to form more products. So that's why your reaction gonna shift to the right. So that's why it's negative X. B is also negative X as well because it's still in the reactant side. And be careful over here for your C, right? There's a 2 in the front. So that's why over here, when you form a product, it's gonna be positive. And so because there's a 2 in the front, so it's gonna be 2x. And then at equilibrium, you're gonna add it, your initial condition and your change condition. So it's gonna be minus x, 0, 2, 0, 0, minus x. This one is 2x. And then you're gonna set up your Kc, right? What is the expression for your Kc for this problem? Yes. So it's gonna be concentration of C, 2 in the front. So that's why we're gonna square it over concentration of A multiply with B. So products over reactants. Now we're gonna replace it with the equilibrium value that we have for each compound here. And so your C concentration is still, it's gonna be 2x, then square. Concentration of A is 0.100 minus x, multiply with 0.200 minus x, and then equal to 4.0. Now your 2x squared gonna be 4x squared over, so we're gonna distribute it in order to get the result. So it's gonna be x squared minus 0.300x plus 0.02 equal to 4.0. And then you're gonna multiply 4 to x squared and then multiply. Just take turns, multiply it. And then you're gonna get 4x squared equal to 4x squared minus 1.20x plus 0.08. 4x squared cancels out. Gonna leave you with, we're gonna move negative 1.20x to the other side. And then it's gonna change to positive 1.20x equal to 0.08. And then x is equal to 0.066 m. Are we done yet? After we find x, are we done yet? Yes, we're not done yet. They asked us to find the concentration of C, right? And so look over here. The expression of C at equilibrium is 2x. So you already find x over here, right? So it's gonna be equal to 2 multiply with 0.066 m. gonna be 0.133 m. Yes. So are we done for this question? Yes, we're done now. So that is the final answer for that problem. So make sure you guys know, like, you guys read the question carefully and see like what they ask you guys to find. The third problem is gonna be reactant product heat exo or endo reaction. Okay. So for this problem, they give you guys the overall reaction, and then they ask you guys whether it's exothermic or endothermic reaction. So look at the reaction. Is it exo or endo reaction? What do you guys think? Yes, it's exothermic, right? Because your heat is at the product side. And then which direction is gonna shift if like you increase the heat?
Left.
Yes, when you increase heat, right? Your reaction gonna shift to the left. And is you react more reactants or you have less reactants if the reaction shift to the left? Yes. So you're gonna have more reactant. Yes. Okay. Move on to question 4. Some of the question that I have in here is like actually from the past exam in 2018. So, yep. Just want to let you guys know.
Excuse me?
Yes.
Will you be able to send like a PDF version of this?
Yes, for sure. But like I able to do it at the end. But like as long as you guys can leave your guys' school email, I can do it.
Okay, thank you.
Mm-hmm. You're welcome. Okay, so for this questions, right, they give you guys the concentration of A, B, and C, but like they doesn't indicate anything, which mean like it's not at equilibrium. And then they ask you guys to compare the Q, and then describe which direction the reaction gonna shift. So how can I able to calculate Q in this situation, in this problem? Remember, like your Q gonna have the same expression. So like it's still the concentration of the products over reactants. So yes. So concentration of C over concentration of A multiplied with concentration of B. And then you just plug in the number because they're already giving you guys everything's here. Then it's gonna equal to 3.0, right? And so your Kc is 3.5, your Q is 3.0. So it means like your Kc is greater than Q, right? So which direction the reaction gonna shift if like your Kc is greater than Q? Yes, the reaction gonna shift to the right. Which means it favor the products. Okay. Then let's move on to number 5. This is the reaction. Calculate for this question over here, they try to ask you guys to calculate K, but they only give you guys the constant, the forward rate constant, and the reverse rate constant. So remember, like when I go over the concept at the beginning, your forward expression is gonna look like this. Equal to Kf, and then multiply with the concentration of the reactants. Your reverse rate gonna equal to K reverse multiply with your concentration of products. And then at equilibrium, these two expression over here gonna equal to each other. So you can make Kf, you can write it down as Kf multiplied with concentration of A equal to Kr multiplied with the concentration of B. And in order to calculate K's over here, when I go over the concept, right, it's gonna be equal to B over concentration of A equal to Kf over Kr. And then you just plug in the number. Kf is 2 and then Kr is 5. So at the end, you're gonna get 0.400. Also pay attention to the significant figure as well, because on the exam, especially for the multiple choice questions, you guys have to route it to the specific significant figures in order to pick the right answer. Let's move on to number 6. Calculate So So for this question over here, right, they try to ask you guys calculate Kc, and then they giving you guys Kp, and they say like at room temperature. So do you guys remember the value of the room temperature in Celsius? Yes, 25. So that means they giving you guys temperatures as well, 25 degrees Celsius. But remember this one, we have to convert it into Kelvin as well. So we're gonna take 25, add it with 273, and then you're gonna get 298 Kelvin. So this is your temperature. And then when I go over the concept with you guys, right? You're gonna get the formula where you're able to calculate Kp based on Kc, right? So this is the formula. Okay. Now they asking you guys to find Kc. So we have to divide both sides by RT delta N in order to get Kc by itself. So that means in order to find Kc, you're gonna take Kp and divide it by RT delta N. Okay. How can we calculate delta N in this case? Which is the change in mole. How can you calculate it? Okay, so it's gonna be equal to mole in product minus mole in reactant. The things to focus here is like we only calculate the one where they in the gas phase only. In here, I given you guys the reaction, they all gas, so that's why we have to count all of them. But like if we have a reaction, for example, where in the reactant or the product side, they have aqueous phase or liquid phase, don't count it in when you calculate the change in mole. Okay, and so over here, there's only one gas on the product side. So you're gonna have one for mole in products, and then you minus mole in the reactant. How many mole you have in the reactant side? Yes, 2. So that's why over here, your delta N is minus 1. So we have delta N, yes. We have the temperature, yes. We have Kp, yes. R is just a gas constant. It's gonna equal to 0.08206 LATM over mole K. So basically we have everything now. So the only thing we have to do is just plug in the number to find Kc. So your Kp is 21 over R is 0.08206 multiplied with the temperatures in Kelvin, which is 298. And then to the power of delta N is negative 1. So your Kc over here is equal to 514. Okay? For example, like this one, assume that is a multiple choice question. And then in your option, right, you got 510. It's not 514, right? There's no 514 in your option at all. But remember, we able to pick the option 510 because it's closer to the result that we calculated. And also, the reason why is have 510 in your option, answer option, instead of like the exact value is because they rounded to two significant figure. So that's why in this question, if she give you guys like an option where it's just a little bit closer to the answer but not the exact value, you can pick the one that closest, the closest one to the exact value that we calculate. Okay. And let's move on to the next question. This one is just another exothermic and endothermic reaction. The reason why I just like keep doing it again and again for this problem, the reason why is because I try to assume that, okay, when this is multiple choice question, right? You got like 300, B 400, 5 is like, C is like 490, and D is like 510, right? I just assume that like you don't have like 514 as in your multiple choice option at all. So in this case, you can pick 510. The reason why is because when you round it to two significant figures, right? So in here, you have three significant figures, right? But then in your answers, they only have like one or two significant figures, right? You have to pick the one that's closest to your exact value. So the reason why over here in the option is only 510 and we pick it as the answer is because look at the exact value that we have, right? 514. There's a three significant figure, right? And so when you grounded it to two significant figures only, so like you want to have two significant figures only for this answer in order to find the best option in your multiple choice. Because like you have 4 at the end, right? You didn't have 5, so that's why you cannot round it into 520 because you have 4 at the end. So because you have 4, you cannot move this number up into one more. So that's why it's gonna round it to 510 instead of 520. Yes. Because like sometime, right, you calculate and then you have the exact value, and then when you look at the multiple choice, there's no option where it's like 514, and then I think maybe you guys freak out and then you guys think like, oh, maybe I did something wrong. But sometimes she just want to you guys to route it to a specific significant figure. So that's why when you routing stuff, it means like you already go below or above your exact value. So that is the reason why, even though you calculate it and then your exact value is 514, then when you look at the multiple choice, there's only these options for you to choose. And so you have to pick the one where it's closest to your exact value. So don't be freaked out if like you guys doesn't see like, oh, I have that answer, but like I don't see it in the option. Did I do something wrong? No. It's just like she want you guys to route it to a specific significant figures. Okay. Let's move on to another question. I know this one, like I already talk about it, like on the concept, but still I want to remind you guys about this. The reason why is because it's an important concept. So that's why I want to do it again and again. So like you guys gonna remember how to do it. And then when you guys see it on the exam, you guys can able to understand and do it well. Add more product. Increase temperature. Okay. So based on the reaction that I give you guys, right? This one, is it exothermic or endothermic reaction? Yes, it's endothermic. Because your heat is in the reactant side right now. And so when you increase the pressure, how it's gonna shift? Remember when you increase the pressure, right? They want to go to, when you increase the pressure, it means like you have a lot of molecules already. So you want to ship it to the direction where it have fewer molecules, right? So because you have heat over here, that means on this side you have less molecule. This side you have more molecule. More molecule. So when you increase the pressure, right, it means you have lots of molecules already. And so in order to reach equilibrium, you have to ship it to the direction where it's gonna react less molecule. So that is the reason why in here, when you increase the pressure, it's gonna shift left. Also, you guys don't need to worry about this because I also indicated on my concept PDF file as well. And so when I send you guys at the end, you guys gonna have all of the information there to prepare for the exam. So when you remove the product, what's gonna happen? Okay, the reason why for this one, right? Which side you have less or more molecules based on the reaction that they're gonna give you, it's gonna depend. Okay, so over here, right? Because it's exo. Let me give you guys an example, right? So example. Okay, over here, right? Based on the reaction that I just give you guys, which one have more molecule? More molecules mean like more mole you guys gonna have. So like which side have more molecule? The reactant or the product side for the reaction that I just give you guys here? Yes. So this one, more molecule. This one, less molecule. Okay? Because they're only one. This one have two. So like on the exam, for example, if she give you guys this problem, right? Maybe she gonna give you guys a reaction. And then you guys have to count the mole. And then consider like, oh, which side have more molecule? And then how it's gonna affect when the pressures increase and when the pressure decrease. And also pay attention when they give you guys endothermic reaction and also exothermic reaction, how it's gonna shift when it's increased the pressure or when the pressure is decreased as well. But like, yes, that is when you know which side have less or more molecule. If she give you guys a specific reaction by count the mole that on each side have. Okay, let's let me give you guys one more example. So aqueous. Okay. So based on the reaction that I give you guys over here, which side have more molecules? Yes. Why not the reactant? There's a two. Reactant have two, product have two. But why like the products have more molecules than the reactant? Why? Yes, because it's not gas, it's aqueous. So that's why we don't count it in. Okay. I feel too good right now that you guys get the idea of that. Okay, so move on to when you guys remove the product. Which direction is gonna ship? Yes, it's gonna ship to the right. How about when you add more product? When you guys add more products, which direction is gonna ship? Yes, because the reason why we want to move to the left is because we have a lot of products. So that's why in order to restore to equilibrium, then you have to go to the left. What is the direction the reaction gonna shift if you increase the temperature? Yes, gonna shift to the right. Okay. Now let's work on free energy problem. Calculate delta G in kilojoule giving okay. In order to calculate delta G for this problem over here, right? Your delta G have the formula equal to delta H minus T delta S, right? They give you guys delta H already, right? They giving you guys delta S as well. What is the value for the temperature? Does they give you guys the temperature? Yes. Room temperature mean is 25 degrees Celsius. So like whatever like she in the exam, right? Whether like any of her questions saying at room temperature, and then you need to calculate something that like you need to use temperature. Remember, always room temperature is 25 degrees Celsius. And this one gonna equal to 298 Kelvin. And so now we have everything. But be careful with the unit. They ask you guys to calculate delta G, right? But like in kilojoule. So like what can you guys do first before you guys plug in all of the numbers here to calculate delta G? Yes, change delta S to, yes, convert delta S to kilojoule. So delta S right now is 74 Joule over Kelvin, right? And when you convert it into kilojoule, you're gonna divide it by 1000. Gonna be kilojoule over Kelvin. Now you got everything. So you're gonna plug numbers in and then get the answer. I'm not gonna indicate the units here because now we got the same unit. So I don't need to put it. I can put it at the end. And it's 22. And then you got negative 29 kilojoule. So just a quick questions, right? If you have delta G is negative, is your reaction is spontaneous or non-spontaneous? Yes, spontaneous, which means is it favor the products or is favor the reactant? If it's spontaneous, then what do you guys have? You guys have more products or you guys have more reactant? Spontaneous mean like, yes. If your delta G is negative, which is less than 0, then your reaction is spontaneous. Delta G less than 0, reaction is spontaneous. Which means you have react lots of product. Reaction proceed forward, which means reaction shift to the right. Okay. Let's move on to the next question. Number 9. Calculate delta G. Okay. So in this question over here, they give you guys the standard give free energy is a negative number. And then they ask you guys like how it can predict whether K is less than or greater than 1, right? And so over here, we're gonna apply the concept is when at equilibrium, right? You have K equal Q. And then remember the formula that we have. At the beginning, right? So gonna be RT, ln, Q. This is the original formula, right? Now at equilibrium, your delta G is gonna equal 0. So you have 0 equal to delta G plus ln, and then because K equal to Q, so now I'm gonna replace Q with K, okay? And then they ask about K's over here, so now I have to separate and then I have to do something to separate K by itself in order to see delta delta G, how the standard give free energy gonna affect the K. And so over here, you're gonna have RTLNK. This one, I'm gonna move it to the other side. So it's gonna be negative delta G0. And then LNK is equal to negative delta G0 divided by RT. In order to have K by itself, we're gonna just put it E, LNK, and then E to the power of everything's here. And so this one and this one gonna cancel out, leaving you with only K. And then it's gonna equal to E to the negative delta G RT. Okay. But look at the questions over here. They giving you guys that delta G0 is a negative number, right? So this one is a negative number. Right? And then your K is equal to E. Remember, we have negative in the front. And also we have a negative number too. So when you multiply with each other, right? This whole term gonna turn into a positive number. Okay? And then when you have E to a positive number, is your K gonna be greater than 1 or less than 1? You can plug in any positive number. Yes, it's gonna be positive. So it's always greater than 1. You can plug in like E square, E's cube, E to the 4 power. Anything when you guys plug it in, it's always greater than 1. So this is the answer. Your K is gonna be greater than 1. If you have the standard give free energy is a negative number. Let's move on to 10. Okay, they give you guys a graph like this as an example. Okay, they asking you guys how many steps in this reaction. Then how many intermediate. So by looking at the graphs over here, how many steps do you guys think in this reaction? Yes, there's a 3 step is because we have like 3 heat in this reaction. And then how many intermediate we're gonna have in this one? Yes, 2, because we have 2 values over here. So this is the intermediate. Okay, then move on the next question. So if you have this graph over here, right? And then they ask you guys to identify forward activation energy and revert activation energy. And then they also ask you guys, is it exothermic or endothermic reaction? Okay. So for this questions over here, right? I'm gonna try to do the forward activation energy first. So here's your reactant, here's your product. So in order to the activation energy is gonna be this area over here. This is forward. Okay. Then by look at the graph over here, we know that there's a two step in this reaction. So we have another forward activation. So this is also forward reaction. This is EA1. Just put this one as 2. And then this one is 1. Okay. And the revert activation rate is gonna be when you go from product to reactant. So because there's two steps, so we still have two activation energy for the reverse reaction as well. And so this is the revert. This is another reverse. Okay, and so by looking at the forward activation energy over here, right? Is it an exothermic or endothermic reaction? Pay attention at the activation energy, right? We have a large activation energy. So yes, in order to get over this barrier, we have to put input energy, which means we have to increase the temperature, which means we have to add heat in order like to process the reaction forward. So that is why it's an endothermic reaction. Need to input energy to pass the large barrier. Let's go to the next question. Oh, the next question is chapter 15. So I'm gonna go over the concept of 15, and then after that we're gonna do some of the problem for chapter 15 as well. So for chapter 15, right, is actually the main concept is about acid and base, the Prentice acid and the Prentice base. So the Prentice acid is like any compound that donate the proton. Prentice base is like any compound that accept the proton. And then I have the examples over here, right? And then when you look at the reactions over here, the product urea is NX4 plus, which means this compound over here, they donate the proton. They donate the proton to NX3. So that's why you have NX4 plus. And so the compound that's gonna donate the proton gonna be the acid. So that's why over here we have XCl as an acid and then NX3 as a base. Okay. So if we have XCl as an acid, what is Cl minus gonna be?
That'd be a little interference.
Yes, it's gonna be the conjugate base. And how about NX4 plus? If NX3 is a base, what is NX4 plus? Yes, it's conjugated acid. Okay. And so for strong acid, right, your equilibrium is far to the right. And then when you have the expression over here, right, when you write down the expression for Ka, which is the concentration of the products over the reactants, is gonna be always greater than 1. And here is the common strong acid. So for this materials in chapter 15, I feel like you guys have to remember some of the common strong acid, weak acid, and strong base. The reason why is because like you guys need to remember in order to use it to determine the property of the salt that she gonna give you guys, whether it's gonna be acidic, basic, or neutral. So I would recommend you guys need to remember the common one in order to prepare for the exam. And so weak acid, equilibrium is gonna be to the left. And when you write down the expression for Ka, it's gonna be always less than 1. And the smaller the Ka, the weaker the acid. And here is the common weak acid. I would recommend you guys remember it. And then, for example, in a questions, right? If you guys being giving like acid like that, like they are bound to hydrogen in order to be an acid. So that's why like if A is a halogen, right? And then it's in the same column. Remember the larger size A is, the longer the bond you're gonna form. And the longer the bond, the weaker the bond. So it's easier to break apart. And so it's like you easily donate your proton. So that's why it's gonna be a stronger acid. The second case is like when you have hydrogen and then the same X compound but like different number of oxygen. Remember, like if you have a lot of oxygen atoms, the more oxygen atom you have in this case, the more stronger the acid. So for example, right, if she give you guys like XClO2, XClO, XCl3, O3, and then she asks you guys which is the strongest acid. In this case, which one you guys gonna pick? Yes, you should pick the XClO3 because it have more oxygen, amount of oxygen, because it have hydrogen, it have fluorine. So like fluorine is the X that I mentioned over here. We have the same thing. It's just the difference here. It's just the number of the oxygen. So yes, this one gonna be the strongest acid. And then in this case, right? For example, imagine you have the compound. This still have the same general formula, but in this case you have different X and you have the same number of oxygen, right? In order to determine like how stronger the acid is gonna depend on the electronegativity of X. And remember, when you look at the periodic table, right, your electronegativity is gonna increase when you go from the bottom to the top, right? And so the higher electronegative of X, the stronger the acid is gonna be. And this is the common strong base. And you guys should remember that too, for the convenience to determine the property of the salt. And then over here, right, I give you guys another reaction. And then you guys can able to see, right, this compound over here, since they donate the H to water in order to create X3O plus over here. So that's why this is an acid because it donate proton, and the water is gonna be the base. And this is NO2 minus. If you have HNO2 as an acid, this one have to be a base. Water as a base, then X3O plus gonna be the conjugate acid. And the strong acid gonna have very weak conjugate base. And the strong base gonna have very weak conjugated acid. And this is the table where you have like the acid, and then when you donate a proton, it's gonna turn into this base over here. And then you're able to see, right? If you have a strong acid, when it's donate a proton and turn into a base, it's gonna be a very weak base. So that is how it's work. And for this table, because there's too many compound, I don't think you guys can able to remember all of them, but just remember the common one that we usually use. Then the second things is how to calculate pH, pOH, concentration of the hydrogen and the concentration of OH minus. So this is all of the formula that you guys gonna need in order to calculate pH. Especially I love this table because it indicate all of the formula in order to find the quantity that you want. And then remember the percentage of ionization is equal to the concentration of X3O plus divided by the concentration of the acid that you guys have, and then multiply with 100. 0 over here just indicate it's just the initial concentration, where this is the acid concentration of acid that you guys have at initial condition. Okay. And also, this is the table for you guys to determine the property of the salt. So for this one, I feel like if you guys able to remember the table, then it's gonna help you a lot. But I don't think like you guys gonna have any problem remember this table, because if you have a strong base, strong acids, right, then they gonna neutral each other out. So that's why your salt gonna be neutral. Strong acid with weak base. So the strong one gonna take over. So that's why you have an acidic salt over here. Weak acid, strong base, strong taking over. So that is why this is basic. Weak acid and weak base is gonna depend. So for weak acid and weak base, you guys have to look at the Ka and Kb value in order to determine whether it's neutral, acidic, or basic. If Ka equal to Kb, then the salt gonna be neutral. Ka is greater than Kb, then it means it's acidic. And Ka is less than Kb, it's gonna be basic. So I feel like the other part you guys can easily to remember, but be careful with this one over here when you guys have weak acid and weak base. Yeah. For this one, you guys have to consider the Ka and the exact Kb value for the acid and the base that you guys have. Then let's move on to the problem for chapter 15. I'm gonna give you guys some of the reaction, and then you guys gonna determine the acid and the base, conjugate acid and conjugate base for this reaction. Okay. So look at the first reaction, right? Is SO4 minus is an acid or a base? Look at the product that the A. Yes. The reason why this one is an acid is because when you look at the products over here, right? This compound donate a hydrogen to water to turn this to X3O plus. So that's why SO4 minus is an acid. Then you guys gonna know water is gonna be the base. SO4 2 minus right now. If SO4 minus is an acid, what SO4 minus 2 minus gonna be?
Conjugate base.
Yes, gonna be conjugated base. This one gonna be conjugated acid. How about reaction B? What is C3X7NO2 is?
Base. Base. No. It's a base.
Look at the reaction. Look at the products that they form, so that you can able to determine whether it is an acid or a base.
It's a base.
Yes. The reason why it is a base, because look over here, right? At first you have 7 hydrogen. Now you have a hydrogen. So that means you accept a proton in order to form the products, right? So that is why this is a base. This one gonna be the acid. X3O plus gonna be the acid because it's donate their proton and then turn into water over here. So if this one is the base, then this one gonna be the conjugated acid. This one gonna be the conjugated base. How about reaction C? Which one is the acid? Which one is the base? Yes. This one donate the proton to NX3 in order to turn it into NX4 plus. So this one is an acid. This one is the base. So this one gonna be conjugated base. This one gonna be conjugated acid. And then how about reaction D? SBF5. What is it? Is it a base on an acid? Okay, look. Yes, it's gonna be the base. This is an acid. I'm sorry to tell you guys that, but the reaction the HF, even though it's an acid, in this case, is not. The reason why is because look over here at the products, right? You just have only one hydrogen here. I mean 2, right? For example. But now you have 2 hydrogen here. So that is mean that you accept 1 hydrogen in order to turn into that ion. So that means this is a base. This is not an acid. So that's why in this reaction, this is a special case. Yes. So the important thing is like not just like, oh, remember that is one of the strong acid, common strong acid, but look at the product that they form. Whenever you have like the number of hydrogen at the product increase, that means they accept the one more hydrogen. So that is a base in this reaction, even though normally we know that HF is a strong acid. So this one is a base, this one is an acid. So yes, remember some of the common strong acid also help. But like when you determine acid and base, the things that I feel like you guys can consider and pay attention carefully is like the products. See like how the product can be formed, and then going back and determine whether it's an acid or a base. Because in some cases, right, your acid is not strong enough comparing to other compound. So that's why it's gonna become a base instead of an acid. So pay attention on that situation if it's ever happened on the exam. And so this is an acid. This one gonna be the conjugated base. This is the base, so this is gonna be conjugated acid. Okay, how about the last one? What is HF? Is it an acid or a base? Yes. In this case, this is an acid because it's donate the hydrogen to water in order to form H3O plus. So that's why in this case, HF is gonna be the acid. Water gonna be the base. And then if this one an acid, then this one gonna be conjugated base. Water is a base, then H3O plus gonna be conjugated acid. Okay, just quick question on this reaction, right? Is HF a strong acid or a weak acid? Based on this reaction only, is HF is a strong acid or a weak acid? Yes. In reaction E, HF is really strong acid comparing to water, right? You know, water is very neutral. It can act as an acid or it can act as a base, depend on the reaction. But over here we have HF, right? So it means this is a strong acid. Okay. So if it's a strong acid, then how about your conjugated base? Do you have a strong conjugated base or you have a weak conjugated base in this reaction? Yes. Strong acid, weak conjugated base. Okay. So the reason why over here, right, you have a strong acid. Then how about water? Is it a weak base or a strong base? Water. Yes. Water is a weak base. And how about when it's from the conjugated acid, right? Is it gonna form a weak conjugated acid or a strong? Yes. So if you have a weak base, right, then it's gonna form a strong conjugated acid. So that is the relationship, and also the main idea of chapter 15. And let's move on to the next question. Number 2. Okay. Write the expression for Ka. At the end today, when I'm finished go over the concept and the practice problem, if any of you guys want to go over any specific problem, you guys can stay and I'm gonna go over that too. And also like after I'm done, if you guys want to leave, and also if you guys want to have the note, just leave you guys school email and then stay a little bit like 1 or 2 minutes to make sure you guys get the note before you guys leave.
Thank you.
You're welcome. Okay. So in this problem, they ask you guys to write an expression for Ka. So for the first reaction, what Ka gonna equal to?
It would be products over reactants, but we don't include water because it's liquid.
Yes. Hold on, let me write down. Okay. So it's gonna be the concentration of CO3 2 minus multiply with the concentration of X3O plus, and then over the concentration of XCO3 minus. The reason why we don't care, we don't worry about the power for each concentration is because there's no number in the front. So that's why it's just like the concentration to the power of 1. So like it's gonna be itself. So that's why we don't need to worry about that. B is gonna be the same too. And then we're gonna ignore the water. So it's gonna be X2PO4 minus multiply with X3O plus, and then divided by the reactant. So X3PO4. Okay. The next one is gonna be similar, but it's for Kb. So I think you guys at this point know how to write an expression for that. I'm just gonna give you guys one quick reaction. And then write out the expression so that you guys can understand the difference between Ka and Kb. Ka is just like for the acid. B is just for the base. And so for this one, Kb gonna equal to concentration of product over reactant. We don't need to worry about the powers. It's because there's nothing in the front. So that's why. Oh, it's just an oxygen. That's not a simple. This is the whole ion. Then let's move on to 15. Okay. Now they ask you guys to arrange in order of increasing acidity HI, HF, XCl, XBr. So in order to arrange it in increasing acidity, it means like you have to arrange it in the order of weak acid, weakest acid, to strongest acid. And look over here, right? They all bond to hydrogen in order to be an acid. And then pay attention, these elements, they in the same column. Yes, we can able to look at electronegativities, but there's another easier way to look for it, because they in the same column, right? And then remember the definition of a strong acid. It means like it's easier. Yes, you're gonna look at the side of the element. So the longer the bond you're gonna form, right? The weaker the bond. And then the weaker the bond means like hydrogen can leave easily in order to donate proton. And so the acid gonna be stronger. Okay. So over here, right, which one have the largest side? I, F, Cl, and Br, which one have the largest side in order to create a longer bond? Yes. This one have the largest side, because like as you go down the column in the periodic table, right, the larger the size is gonna be. So I don't know if I can able to pull up the periodic table, but you guys can look at the periodic table and you guys can see I is like at the near the bottom of the column of the halogen. And so this iodine is have the largest size. So when it's form a bond with a hydrogen, right? So larger size. This one is a hydrogen. This one is iodide. So it's gonna create a longer bond. And then the longer the bond, the weaker the bond. So that's why your hydrogen can easily break apart and donate the proton to another compound. Which one have, which is the next larger size? Fluorine, fluorine, FCl and Br, which one have the next larger size? Yes. So this is first largest, second largest. Which one is the third largest? Yep. This is the third largest. So F is the smallest one because it's way at the top. And so as we already say, right, the larger size the halogen is, the longer the bond's gonna form. The longer the bond, the weaker the bond. So hydrogen can leave easily to donate the proton to other compound. So that's why HI gonna be the strongest acid. First strongest acid. Right? Which one is the second strongest acid? Remember HF? F have a smaller size comparing to like I, Cl, and Br. So the smallest the size you have, the shorter the bond. Yes. So the second strongest acid is HBr. So Xi is the strongest. HBr is the second strongest. What is the third strongest acid? Yes. Let's see. Third strongest. What is the weakest acid? Yes. Weakest acid. So the order is gonna be HF less than HCl less than HBr less than HI. So this is the final answer. This concept over here, I already put it in the concept note. So yeah, you just need to write down this one as an example, but like the concept or how to solve it, I already put it on the concept file. Then move on to the next problem. Okay, so let's work on the first question first. Why are the aqueous solution of salts such as CaCO2 is neutral? So this is CaCO2. This is salt, right? What ion when you dissociate the salt? What ion is gonna make? Yes, it's gonna dissociate into Cl2 plus and Cl minus, right? Which one we can make it as an acid and which one we can make it as a base? Remember, like metal, usually it's easier for you to make metal as a base. So over here, calcium is a metal, right? So we're gonna, when it's turned into a base, it's gonna have this type formula. Cl minus is gonna react an acid. Usually the non-metal is the one that easily to become an acid. So this one gonna make HCl. And then as you already know, CaOH2, yes, it's a strong base. HCl is also a strong acid. So that's why when you have strong base and strong acid, it's going to neutralize each other out. So that's why at the end you have a neutral salt. Yes. Okay. Take a look at the other compound. Why is it basic? Okay. So which ion is going to be dissociated? Which ion we going to get from this salt over there? Yes, we're gonna get Na plus, this one, and X2 minus. The reason why I know NX2 is has a -1 charge is because the overall compound, right? it doesn't have any ion and doesn't have any charge at the end. So that's why I know the charge is 0, right? And then we know sodium is +1. So in order to have the total charge equals 0, and X2 have to be -1 in order, like when they add it together, +1 -1, you're gonna get the total charge equals 0. And so we can make the metal into a base. So it's gonna turn into NaOH. This one gonna turn into acid. So it's gonna be NX3. Okay. Remember, NaOH is a very strong base. NX3 is a weak acid. Sometimes it can be a weak base as well. In some case. Some cases. So that's why overall we have a basic salt here. So in order to determine the property of the salt, you have to look at the salt, right? And then know which ion you're gonna form when you dissociate a salt. And after that, turn the metal element into a base, and then the non-metal element into an acid. And then remember the common strong base, common weak base, common strong acid, weak acid, and then overall you can able to determine the property of the salt. So that is the reason why I tell you guys to remember some of the common compound or some of the common acid and base in order to determine the property of the salt. The next problem, move on to the next one. So we have this question over here. Yes, it's a liquid. Yes. Oh no, wait, hold on. I think it's in aqueous. And so look at the questions over here that we have, right? What we have to do. What is the first step that we have to do? Yes, we have to do the rice table. Okay, what do we have initially? Yes. So at initial condition, right, you have 0.1 m for CX3COOH. And so at the change condition, right, you're gonna form the product. And so this is why it's gonna be plus X. And also X3O plus is also a product, so it's gonna be plus X as well. The reason why there's nothing in the front is because there's no coefficient. So that's why if it's like a 2 over here, we're gonna have 2 plus 2x. And then your reactant is gonna have a minus sign. So at equilibrium, you're gonna have this expression. Plus x. And now they're giving you guys Ka already. So now we need to write the expression of Ka and then try to find the x, which is also the concentration of X3O plus over here. So in this case, right, because you doesn't have any coefficient in front of the compound, so that's why in here your value of x is also equal to the concentration of X3O plus as well. And so you're gonna have the concentration of the products over the reactant. So it's gonna be concentration of XC3OO CX3COO minus multiplied with the concentration of X3O plus divided by the concentration of CX3COOH, which is X multiply X over 0.1 minus X equal to 0.1. So you have X squared over 0.1 minus X equals to 0.1. And then it's gonna be X squared equal to 0.01. We're gonna distribute it. Minus 0.1 X. Move everything to the other side so that we have the quadratic equation x squared plus 0.1 x minus 0.01 equals 0. So in order to solve this one, we're gonna use the quadratic formula x equal to minus b squared minus 4ac over 2a. And so what is your a over here in this equation? Yes, a is 1. What is b? Yes, 0.1. What is c? Yes, c is minus 0.01. Okay, so now we need to just plug in the number. So minus b gonna turn into minus 0.1 plus minus b squared is 0.1 square minus 4 multiply a is 1, c is minus 0.01, and then over 2a, a is 1, so 2 multiplied by 1. Then you're gonna get x equal to minus 0.1 plus minus. I put this whole thing into the calculator. Then I got this number. And over 2, so your x gonna be minus 0.1 plus divided by 2, or x equal minus 0.1 minus verify over 10 over 2. This one gonna give you 0.0618. This one gonna give you minus 0.1618. Because like the concentration is always positive, so we're gonna eliminate this options over here. And then we're gonna only have x equal to positive values. And so we have x over here, right? what is the concentration of X3O plus? I already mentioned that we don't have any coefficient in the front. So that's why your X value over here gonna equal to the concentration of X3O plus as well. And how to find the pH? How to calculate the pH? Yes, it's gonna be minus log concentration of X3O plus, which is negative log of 0.061A equal to 1.21, which means this is a very strong acid based on the pH. Okay, and let's move back to the concept for 16. So the concept for 16 is like, it's not a lot. It's just deal with the Henderson-Hasselbalch equation, as I already put over here. And also how when you have like higher concentration of base than the acid, it means like you have pH is greater than pKa. Concentration of base less than the concentration of acid, pH gonna be less than pKa. Then you also need to remember the function of buffer, how like it's gonna be used in order to maintain your pH, which mean like it's gonna controlling the pH as well. And weak acid components gonna neutralize the added base. Weak base components gonna neutralize the added acid. And over here we have a different definition of acid and base. This is Lewis acid. So Lewis acid is a substance that accepts a lone pair of electrons. So remember, the Prentiss acid is like, the Prentiss acid and base just only consider about the proton. And in here, your Lewis acid and Lewis base, they deal with pairs of electrons. So the one that accept the electrons gonna be acid. The Lewis base gonna be the one that's gonna donate a lone pair of electrons. And also you guys need to understand the concept of the formation constant Kf as well. It is an equilibrium constant that describes the formation of the metal complex from a pre-metal ion and its ligands. When you compare it to Q, if Q is greater than KSP, it means the reaction will favor the reactant formation and the compound will precipitate. If it's less than Q, then the reaction will favor the products and compound will be soluble and will not precipitate. Yes, the lower the pOH, the stronger the base. Yes. And then if you have the high pOH, it means like you have a weak base. That's basically how it's worked. Yeah. So for chapter 16 concept, is basically it. And then remember, right, for this one, if I give a practice problem, it's kind of like a little bit similar with the other two chapters as well. So that's why I don't have any practice problem for chapter 16. The reason because this one, remember like when we have the worksheet in class, right? You just only need to plug in the formula. That basically is it. And then she gonna give you the concentration of the acid and also the concentration of the base as well. For example, right, she give you guys concentration of CH3COOH, right? This is an acid. The base gonna be from the salt. For example, NaCH3COO. Yes. So this is the base. You're gonna plug in the concentration of the acid or and the base in order to calculate the pH. So basically, you guys need to remember the formula in order and read the question carefully and see whether which quantity she want you guys to calculate. And then for the KSB, it's gonna be, for example, she give you guys a reaction. Okay, the KSB gonna equal to the concentration of the reactant side. So that is the expression for the KSB. Also be careful with the coefficient in the front. For example, if they have 2 and 3 in the front, right? Then your concentration of A is gonna be square and concentration of B is gonna be to the third power. And then maybe she's gonna ask you guys to compare it with Q and see how the reaction ship. Which direction? Reaction will ship. So that's why I don't have any practice problem for you guys for chapter 16. But if you guys have any problem that you guys specifically want me to go over, you guys can send it to me too. But if you guys don't have any questions, you guys can leave your school email, and then I'm gonna send both of the concept slide and also the practice problem as well. If you guys don't mind, just stay a little bit so that I can make sure you guys receive the note, because if you guys leave before I send it and then you guys don't receive it, I'm just there's no way for me to contact you guys. So just stay for 1 or 2 minutes and I'm gonna make sure you guys receive it.